Hello, my name is Nisa and welcome to our group project presentation. Today we will presenting the technical analysis of a pressure cooker, focusing on the materials used, the production methods, and how the parts are assembled. What is pressure cooker? Pressure cooker are a unique kitchen tool that they trap steam inside to prevent the hot steam from escaping the cooker. The process of trapping heat inside the pressure cooker makes water boil at a high temperature and creates pressure to allow cooking faster. The different materials that make up each individual piece are chosen for high heat and pressure resistance for regular use, with the appropriate tolerance so that the pressure cooker operates correctly and has a safety tolerance for long-time usability. Let's break down the pieces of a pressure cooker and the materials that are available for the individual pieces. First one is pot body. The main body of the pot is made from stainless steel for corrosion resistance and strength, and aluminum base is often included for enhanced heat conductivity and cooking efficiency. Conical pot body. This part shares the same materials, stainless steel for the durability and aluminum for heat conduction. Its shape supports structural integrity under pressure. The other one is lid. The lid must handle high pressure and seal the pot. It's crafted entirely from stainless steel for reliability and resistance to corrosion. The other one is control valve. The control valve is crucial for safety. It releases excess pressure. Stainless steel gives its strength, while plastic components offer flexibility and heat resistance. Here, lid handle, pot handle, and helper handle. These are the same things. Handles are made from plastic or phenolic resin, which resist high temperatures. Stainless steel reinforcements are sometimes used for extra durability. Superthermic base. The superthermic base is a multi-layered heat conductor. Aluminum provides rapid heat distribution. Stainless steel adds strength, and liquid silicon mixture enhance thermal resistance. The last one is silicon gasket. This ring ensures the lid seals tightly. Silicon rubber is flexible and can endure both high temperature and pressure.
Hello everyone, my name is Ceren. I would like to describe the production of the materials used in the construction of the pressure cooker. First material is stainless steel. The production of stainless steel involves careful selection of raw materials, including iron ore, chromium, nickel, manganese, molybdenum, carbon, silicon, and scrap steel. The combination of these materials ensures the quality, durability, and performance of stainless steel products. The process involves the melting raw materials, refining argon-oxygen decarbonization, casting mold formation, hot rolling, descaling, annealing, pickling annealing, cold rolling, finishing surface treatment, and cutting and shaping. Each step is optimized for efficiency, sustainability, and product performance, ensuring that stainless steel exhibits the properties required for various applications, including durability, corrosion resistance, and aesthetic appeal. Second material is aluminum. Bauxite, a clay-like soil found around the equator, is used to make aluminum. The bauxite is mined, washed, and ground into alumina, or aluminum oxide. The alumina is extracted using lime and caustic soda and dried to a white powder. The aluminum is then produced in a metal plant using electricity, carbon, and carbon. The liquid aluminum is cast into foundry alloys, sheet ingots, or extrusion ingots, with various applications. The aluminum is highly ductile and can be used in various products, including aluminum alloys, automotive components, and wheel rims. Third material is heat-resistant silicone rubber. Silicone rubber is a polymer made from silicon, oxygen, carbon, and hydrogen. Its basic building block is polyoxylene, which is obtained by reducing silica at high temperatures with carbon. The molecular signs chemically react to form long chains of polyoxylene, which are highly resistant and can stretch without breaking even at high temperatures. Cross-linking agents are used to cross-link the polyoxylane into hard rubber. Different curing systems are used, including adhesion cure, condensation cure, and peroxide cure. Special flares and heat stabilizers are also used to improve heat resistance. Fourth material is heat-resistant plastics. Plastics are made from natural materials like cellulose, coal, natural gas, salt, and crude oil through polymerization or polycondensation. Crude oil is refined before use, breaking it into lighter components. Polymerization and polycondensation are two processes used to create plastics with polymer chains varying in properties, shape, and size based on the monomers used. Fifth material is phenolic resin. Phenol and formaldehyde are commonly used in the production of phenolic resin. The process involves a mixture of phenol and formaldehyde in a reactor, which undergoes precondensation to produce low molecular weight resins. The resin formation or polymerization stage involves raising the pH with an alkaline catalyst. After curing, the resin cools and solidifies. It can be further granulated, pulverized, or dried to achieve desired particle size and shape. Post-treatment processes like grinding, sieving, or drying can also be used to modify the resin's properties. Sixth material is pressure safety valves. Sand castings serve as the basis for the production process of metallic valves. The molds are prepared for particular items. The metal is melted by the induction furnace. After the product cools, the liquid metal is placed into the molds and then machined, assembled, and packed. The production of a pressure or steam relief valve requires careful engineering to ensure safety and dependability under high-pressure conditions. It starts with creating the valve based on specific needs related to applications, such as flow capacity and pressure rating. Durable materials such as stainless steel or brass are chosen for their robustness and resistance to heat and corrosion. Typically, the valve body is formed through casting and forging. The machine to meet specifications, the essential parts like the seal and spring are installed and arranged to operate. And the last material is aluminum core. A roll of aluminum foil initiates the manufacturing process. To produce adhesive lines, the aluminum foil is passed through a printer. A stacking machine is subsequently utilized to cut it to desired size and arrange it in stacks. To form a honeycomb block, the layered sheets are pressed in a heat machine to set the adhesive and bond the foil sheets together. Portion of the blocks can be created. The thickness can be modified to satisfy the client's requirements. Subsequently, the honeycomb is expanded. In the end, we manufacture bespoke composite panels by fusing the expanded aluminum honeycomb core with the skins designed by the customer. These panels assist our clients in reducing cost, weight, and materials by offering stiffness and flatness with minimal weight increase.
Hello everyone, my name is İlayda. Today I will be representing the main manufacturing process used in the production of pressure cookers. This process involves several steps. Let's go through them one by one. Firstly, I want to mention about drawing. Drawing is a forming process where the cross-section of rod, wire, or tube is reduced by pulling in through the die. This technique applies tensile forces and is used for metal, plastic, and even glass. There are two main types: sheet metal drawing and wire, bar, or tube drawing. Deep drawing is a specialized form of the drawing process. One method of producing sheet metal is deep drawing. Deep drawing is a more advanced version of drawing process. It involves forming a flat metal sheet into a hole or convex shape, such as cup or cylinder. This is achieved by pressing the sheet into a die using a punch. Ductile materials like aluminum, copper, and stainless steel are ideal for these methods. It's commonly used in the production of cans, fuel tanks, and kitchen containers. When deep drawing is used, the part has complex shapes, features point in different directions, or when specific proportion and thickness are required. Advantages of deep drawing. These methods offer several advantages: high production efficiency, cost effectiveness, material saving, and improved machine properties of metal. This process has a crucial problem. The most common ones are wrinkles and tearing, caused by uneven deformation during the process. Proper control of blank holding force and die design help prevent these defects. Application of deep drawing process in different industries such as automobile industries, aerospace industries, household application, electronic industries, packaging industries. The next process is cutting. Cutting is essential to shape material into required form. Various methods include mechanical, laser, and plasma cutting. These provide speed, precision, and flexibility in manufacturing. Trimming removes excess materials, especially flesh from forging. It's the finalized step and can be done manually or with laser or robots. It ensures clean edges and precise parts. It's used in a wide range of industries. Again, the automobile industries, aerospace industries, plastic mold production, textile industries, and etc. The other step is polishing. Polishing improves surface smoothness and appearance. There are several types of polishing: mechanical polishing, chemical polishing, electronic polishing, vibratory polishing. And polishing advantages: no risk of tear or wear on the surface, increase aesthetic and improve surface finish. And there's two disadvantages in this process. A messy process and a variety of equipment is required, some of which are costly. The next step is sanding. Sanding smooths the surface and prepares the material for the next step. It removes roughness and gives an aesthetic finish. The following are several of advantages of sanding process. Sanding provides material a smooth surface that can be customized for your requirements. This sanding process removes defects and prepares the material for the next manufacturing process. The next one is flattening. Flattening evens out surface using pressing, grinding, rolling, or laser leveling. It improves quality, reduces material waste, and increases production efficiency. And application in industries, automobile and aerospace, such as fuel tank or panels, and packaging industries for metal cans. The next one is punching. Using a punch press, a punch tool is pushed through the workpiece to create a hole. Punching is a shaping method. It is possible to punch a variety of materials that are accessible in sheet form, including paper, sheet metal, and some type of plastic sheet. Punching can produce holes of various shapes. This process saves time because it's quick process. The last process is reverting. Reverting is a manufacturing procedure that permanently joins two materials using specialized equipment. There are several types of reverting, which is blind or pulp revert, solid revert, tubular revert, split revert, and flash reverts. The reliability increases because reverting creates a strong junctions. Reverting is widely used in sectors such as, again, aerospace, automobile, construction, shipbuilding, and electronics for lightweight, strong and durable joints. The manufacturing of pressure cookers requires this combination of process.
Hello everyone, my name is İlayda. Today I'm going to talk about how the pressure cooker is produced. My friend Elif gave you some information regarding these processes, and I will be showing you how they are used in the manufacturing of pressure cooker. From raw material shaping to the final touch, each step is carefully carried out to ensure both functionality and durability. Let's begin with the first stage. And firstly, we will look at the manufacturing of the body of the pressure cooker. The process starts with deep drawing, a widely used sheet metal forming technique. In this method, a flat sheet of metal is pressed into a die cavity using a mechanical punch or press. This transforms the flat sheets into a hollow, cylindrical shape, which forms the base structure of the pressure cooker. Usually, two stages are involved. In the first drawing, the initial shape is created. In the second drawing, the part is further stretched to make it thinner and longer, achieving the desired shape. This step is crucial as it lays the foundation for the pressure cooker body. After deep drawing, the next step is metal spinning, also known as spin forming. This process is used to shape the metal into a symmetrical, round form, ideal for the body of the cooker. A lathe machine is used here, where a spinning tool applies pressure to the rotating metal. This causes the metal to gradually follow and take the required shape. Metal spinning allows for smooth, even contours, which are essential for both aesthetics and pressure distribution. Once the shaping is done, any excess material must be removed. That's where trimming comes in. This process cuts off the unwanted edges of the workpiece, giving it a clean and precise outline. Trimming helps maintain dimensional accuracy, which is important for parts that need to fit together tightly in the final assembly. Next, we apply necking, a controlled deformation process. This is where a small section of the material is deliberately thinned to form a narrowed area or neck. This technique is often used to prepare the body for joining with other parts. Necking ensures a tight fit and also adds structural flexibility where needed. After the forming processes, the metal is washed thoroughly. This step removes oil, dust, and metal residues from previous processes. A clean surface is essential before moving on to polishing or coating. Polishing is then applied to smooth out surface imperfections and give the pressure cooker a shiny, finished look. Both the outer body and edge slots are polished using abrasive materials or tools. Polishing not only improves appearance but also prevents corrosion and makes cleaning easier. The next process is sanding. This is done using coated abrasives to flatten and smoothen surfaces, especially the bottom and inner parts of the cooker. Sanding prepares the surface for coatings or finishing touches and removes the fine scratches or irregularities. In some parts of the pressure cooker, such as handles or brackets, a round metal may need to be flattened. This is done in the flatting process, which uses a press to convert round profiles into flat ones. Next, punching is used to create precise holes in the sheet metal. A punch press removes material using a shape tool called a punch. These holes are essential for later steps, especially for riveting or attaching additional parts. Finally, we come to riveting. In this process, rivets are inserted into the pre-drilled holes of the parts that need to be joined. Then, the tail of the rivet is deformed, usually with a manual or rivet gun, to create a secure, permanent connection. Riveting is a reliable method for assembling components without welding or adhesives. With these processes, the manufacturing of pressure cooker body is ended. Now, we will move on to the manufacturing of the cover. The cover of the pressure cooker is also produced using the same methods that are applied to make the body of the pressure cooker, such as deep drawing, edge cutting, necking, washing, outer polishing, inner sanding, and punching. Now, we have a video about the steps we talk about, which are the processes of pressure cooker making. Firstly, the metal is pressed and transformed into a cylindrical shape. After that, a second deep drawing process is used to make the metal longer and thinner. Spinning is used for give metal the required shape. Then, trimming is the cutting operation. We wash our metal to make it clean and remove the dirt. Polishing is used to smooth out the metal. Bottom sanding is done to flatten the surface. Then inner sanding is also applied to the metal. Flattening process ensures a flat bottom. Punching creates holes in the metal surface. And finally, riveting is used to join parts. And it's the final product of our pressure cooker. Then let's take a look at the production line of the pressure cooker. First, deep pressing line is the place where the first deep drawing process occurs. After that, oil lubrication is applied to the metal before the second deep drawing process occurs. With these steps, the metal is shaped into a deep cylindrical form, which makes the basic body of the pressure cooker. Then, cutting the edge and necking are done to give the metal's rim the desired shape. The production line is completed with the final part of the line, which is flap beading. Then, we have the technical drawing of pressure cooker. As shown in our technical drawing, the internal structure and components of the pressure cooker are clearly visible, showing how each part functions safely under pressure. To summarize, the manufacturing of a pressure cooker involves a series of precise and carefully controlled processes, from shaping and forming to surface finishing and assembly. Each step plays an important role in ensuring that the final product is not only functional but also safe, durable, and visually appealing. Pressure cookers combine smart design with high-quality materials like stainless steel, aluminum, silicone, and heat-resistant plastics. This ensures long life, safety, and strong performance in everyday kitchen use. Together, these elements make the pressure cooker efficient, stable, and reliable. Here our references are presented. Thank you for listening.